Okay, we're going to go a little bit further with Tableau and making maps in Tableau. This requires that you've gone through part 1 and part 2 of the other videos that we've made on this topic. I'm making all of the data I'll be playing around with here available for y'all to work with. I should have all of this. Let's see, I have that and that. Yeah, over here in this directory, it looks like, for the most part. So I'll just be pulling it from here. These are all CSV files. I believe they're all CSVs. Yeah. And in Tableau, to import a CSV, you want to connect to data, and that would be read as a text file. So go ahead and download those files. I'm going to go ahead and import one of them. So let's see. I'm going to start with the obesity rates by county. I believe this is from a tutorial. Fertility rates I found on a different data site. COVID-19 data is from a week ago, and it's from GitHub. And this directory file is the location of all the Starbucks in America, or maybe internationally. That's from Kaggle, I believe. This fast food restaurants is also from Kaggle. So a bunch of different sources, although all the same format. Let's see. Let me hit open, and we can take a look at the data. So let me go ahead and go to our sheet. And what can we do with this data? Well, first of all, let's take a look at it. Remember, if we want to create a map, we need to use an icon that has like this shape to it, you know, like this little globe icon. So down here you can see we've got latitude and longitude as measures, and in the previous lesson, I guess we were adjusting this to be a dimension, that sort of thing. First of all, I didn't see that as an option because this is generated. It's not that we couldn't create a map with these, this is not what we want. What I'm going to try to do is show you a bunch of different ways to make maps from a bunch of different types of data. Some of that data will be clean and some of it will be dirty. Let's see. I'm going to go up to state here and drag this down to our worksheet. And it will generate a map of the United States for every place that we have a data point. You can see when we hover, it just says the name of the state. We've got Alaska and Hawaii. If we decided to exclude those for whatever reason, we just click this exclude button. I guess I'll do that, although it makes this a little bit more methodologically unsound. But it does make it so I've got a nice big picture here, so you can definitely see my map in this video. All right, so what do we want to look at? Well, we want to look at obesity rates. If you notice here, we just have the obesity rates for 2012 and 2013, so this data is not up to date. Well, nonetheless, let me take this obesity rate one. Let's say that's the one we want to play around with. Now, we've already selected state, right? So I could take obesity rate 2013, and for instance, I could drag it to size. But I think color would work better since we're working by state here. Okay, so you see everything changes, and when you look at the obesity rate, it is a staggering 1,398 for California. That doesn't really seem to make sense. That's not a rate. And that is because, once again, this is being calculated as a sum, and it is being read as a continuous variable. This is a discrete variable. So I'm going to switch it to discrete, and ta-da, we get this rainbow. Now when you hover over, you're going to get, looks like really wacky numbers still, 7,848.6000. You can see it's still doing sum, even though we've changed it from continuous to discrete. And that's because this is still being read as a measure, and that measurement is of the sum. And that's not what we want. We want attribute, I think. Let me switch that. That's a lot better. Now when you hover over, you should get numbers like 26, 24, etc., etc. Good. Okay, so that's a nice representation of the obesity rate by state. I do not remember the methodology of this data. Again, I just want to show you as many examples as possible how to get something to visualize. Let's say we wanted to look at this at a different level, like at county instead of state. We should be able to take county and drag it down here. Now we're seeing the individual counties within the state, and you can see the obesity rate is the same all the way through, right? Same all the way through with Nevada. Let's click on state and hit delete. Okay. And so now you can see it's no longer using state as a measurement. Well, it kind of is. It's got the colors there by state. That's pretty cool. You'll notice a lot of the data is missing here, though. Specifically, all these gray areas. That's where data wasn't reported. You'll also notice if you hover by state, it's just going to give you the value of the entire state, not of the county. So what if we wanted to try to see the individual values by county, even though we've got that right here? I would start over. So we could keep what we have, just make a new sheet. I'm just going to drag down county. I'm going to do the same process we did a minute ago. Sorry, I was right-clicking, I think. Drag down county. It's not quite how we wanted, but that worked. Okay. And then I'm going to take obesity rate and drag it to color. There we go. And we hover over, you're going to see you're still going to get this really similar values, but there are there differences? Let's see, I want to zoom in. Is it still being read by on a state-by-state basis? I guess that's what I'm wondering. It kind of looks like it. 27's 26, but that's in Oregon. So yeah, it's still being read on a per state rather than a per county basis, it appears. Washington is 27. What is this? Idaho is 29. Yeah, so that seems wrong. Let's see. Let's look at the data if that's true. So say here's Alabama, and if you look at the data, you'll see, yeah, actually, for all of Alabama, it has the same obesity rate for every single one of those counties. And you'll see it switch over until we get to Alaska. So my assumption would be that some of these other values are different. They look different on a per county basis, but the obesity rate is just per state. So going back to our display here, it doesn't make any sense to do county unless we just wanted to indicate which counties did not report. And this would make a lot more sense as a map. I think if we dragged over this other version of state, it's just going to show the same thing. I'm not sure why there's duplicates of that. Okay, so that was obesity levels by state. Let's walk through another one to get some more practice. Let's work for something that's working with latitude and longitude values here. So I'm going to grab fast food restaurants. Okay. Let me go ahead and save this. Sure, I'll just call it that for now. It looks like I've already got fast food restaurants loaded here, which is kind of nice. If I didn't, I could always drag it in. Let me just click here. Oops, did not mean to do that. It is trying to join these two, and we do not want to join these. So let me cancel that. All right, let's see. Let's see what happens if I drag this guy over. Oh, we're still doing a join. So the reason it's trying to do this join is because I think we're looking at this data source right here. Let me go back. Man, I hit that a lot. Okay, so here's where we were previously. Let's see. I want to add another data source. So I'm going to do it as a different way than I just did because that wasn't working at all. I'm going to go up to this icon up here, hit plus. And again, we're doing a text file, so there's CSVs. Let's see, what do we say? Fast food restaurants. Let me click on that guy, hit open. And let's see, I'm going to click a new sheet. Make sure that fast food restaurants is clicked, not the obesity file. Again, what was happening a minute ago is we had our first data set loaded, and when we tried to load a second data set, it wanted to link the two, and it would need a common variable in order to do that. Such as state, right? So it seems doable, but you'll notice here in fast food restaurants, it's actually province, not state. So that would be problematic. We wouldn't be able to do much there. Okay, so for fun, if we take latitude and longitude and drag them over, we're not going to get anything here because again, these are generated. It's just not going to do anything there. Let me grab these latitude and longitudes, drag them over, And we get kind of a weird value here. So I'm just seeing Missouri. Let me zoom out. That's all I see is Missouri. All right, so that wasn't very helpful. Let's get rid of that stuff. So these latitude and longitudes aren't helping. Now what we did, our last lesson, I believe, is we converted this to a dimension. We converted this to a dimension. I can click on both of these now and drag them over. And we're going to get this really weird, confusing map. So it's showing, it has the generated as well as the original. That's not going to work either. So I'm going to delete all that stuff. Okay, how are we going to get this to show? This is kind of issues I've had with like every map when I first open it up. Well, we've got province. We saw that earlier. Let me drag that over. That's getting a much more predictable, easy to read result. Now again, we've just got a map that just shows the actual individual states, right? What is it that we were looking at? Fast food restaurants. Well, here's the number of records. If we dragged this to color and let go, let's see if that's going to work. Yeah, so this indicates that California has 676 as opposed to Nevada, which has 135. These numbers seem a bit incorrect. So again, if you look at the methodology of the study, it's counting not all restaurants, but certain restaurants, certain franchises, I think. And this data is old. But nonetheless, it's good for a little practice thing. Now, whenever I show something like this, it makes me think of the importance of your methodology. And what I mean by that is it's very easy to have a map like this and try to reach conclusions from it. That would be incorrect. For instance, California has 676 fast food restaurants. And that looks like it's the most. Well, even if it's not the most, it's quite up there. So what can we glean from that? Well, if we were going to compare that to our obesity project and say, well, its obesity rate is really low relative to these other states. It's at 24.1. So can we conclude that states with more fast food restaurants have lower obesity rates? Well, first of all, from a logical standpoint, that doesn't really stand to reason. But beyond that, as I was saying, this is a methodological error. There are more people in California, more people in all the states that surround it, more people. It's probably the most populous state. If it's not, it's up there, right? The same with Texas, right? Maybe that's the most. I mean, these are a lot of people, and similarly with places like Ohio and Florida, very heavily populated states. So it should not be a surprise to any of us that the most heavily populated states have the highest number of fast food restaurants. And we're not talking about population density, we're talking about statewide population. So we would want to reach a conclusion based on this statewide data because it would be inaccurate. Let's try doing something with latitude and longitude. That's what I said last time, and then I think in my head I was thinking about this Starbucks data. All right, let me go through the same process here. I'm going to hit this plus text file and grab, I believe this is called directory.csv. I did not change the file names of these data sources. They're just as they were downloaded. I thought it would give us some opportunities to see messy data. This would be an example. So you can see a few things here. First of all, we have street address. We can't do anything with that. We have city. In theory, you could do something with that, but it's difficult. And then we have state, province. Okay, that sounds really helpful. This first one is listed as 7, though. That's not very helpful. Country. Okay, so this is international data. You'll see we'll have a lot of null values. There's data that we have no interest in, like phone number. Time zone is not clarified. I guess it's just talking about what time zone it's in. We don't have any other time measurements here, so I don't know what we could do with that. Anyways, then we have latitude and longitude. That's what we're going to use for our geospatial. Let's see, I think I already created a new sheet. Yeah. So it's called directory. Let's try this. Now again, when we drag this over, it's probably not going to be too friendly in making a map. Yeah, we've got one point here. In the middle of the Atlantic Ocean. All right, so that didn't work. Oh wow, it's counting all my zooms as a step as I'm undoing. I was just undoing a lot. Well, let me try our trick. Latitude is change, let's see, convert to dimension. Latitude and longitude. Okay. Let's see if we have more luck now. Yes, we did. So you see that was really different from the last data source we worked from, which did not really seem to have useful latitude and longitude data. Okay, so we played around with this our last project, but I'm gonna again, or our last lesson, pardon me. I'm gonna again use this rectangular marquee tool and drag a block around, roughly North America. And with the pop-up, I'm gonna say keep only, kick everything out, except that. And you can see these are all still highlighted, so it's a good idea to click away so your map looks normal. It's confused me before this for sure. So we are just getting a list of the latitude and longitude of these actual locations. It's not very useful, right? So what else could we do with it? Well, I mean, we could add store name, but we know what the store name is. It's Starbucks. We could add phone number, but as we saw earlier, that's pretty incomplete. There is a street address. We could use that if we drag that to detail. Now when I hover over, it's just going to tell you the street address of each one. So is this useful? Well, not really. With latitude and longitude data, what we're usually going to be able to do, with the exception of boundary data, is just show points. What we would potentially be able to do is use these latitude and longitude values to create density maps. But that would have to, we would be required to define bounds and things like that. It gets a little bit complicated. Not that it's not doable, but it would be more interesting and useful than just these dots. Okay. Let's do an international example where we don't kick out all the data that's not having to do with America. So this terribly named file is on fertility rates. I just Googled international fertility rates or something like that. So new data source, text file, API, SP, DYN, etc., etc., etc. All right, let's take a look at this. So country name, that's going to be useful. And then we have all these columns with generic names, and there's a lot of them. So my guess would be that this is some sort of time series where it's showing the fertility rate of a given year, the year before, the year before, the year before. So how would we plot this? Well, we'd have to find out which of these is the most current, or that sort of thing. So my guess would be, I don't know if you can see this. It's really messy data. But here are our column names. Data source, that's a helpful column name. World Development Indicator, okay. And then these Fs, F3, F4, F5. So after that, there's a null or blank column, and then there's just this last update. Like this is not formatted in a data-friendly way. Then we have another null, so this is just like someone like double spacing their document for the title. All right, and these are the real quote-unquote headers. Country name, country code, indicator name, indicator code. And so what you can see here is that these numbers, 1,960, 1,961, that's actually a time series. This is being misinterpreted as numeric data that's actually years. So based on that, we can see the most recent information is from the year 2017, and it's this column F62. Now, luckily, these fertility rates seem to be measured correctly. There are some null values, but they are not connected to countries. They're, I think, null all the way across. So maybe they are. Let's see. Oh, yeah, Dominica, no entry. So some of them do have Curacao. Thanks a lot. We have some blanks. All right. New sheet. So based on what we figured out, I believe we would want to take this data source dimension and drag it over, and that should be the names of our countries. Okay. So there they are. I'm going to click on Show Me, and let's see if we can get something cool going with a map. No, it doesn't look like it's friendly yet. And remember, a map, like if we hover over this little thing, it says it needs at least one geospatial, and then it can also do an additional measure up to 2 more. Well, let's grab another measure here. Let's see, what was the one we figured out was our last one? Was it F62? Let's find out. So I'll drag that over here. And now we got numbers. Those numbers look wrong to me, though. Go back to our data source really quick. F62. Yeah, that's 2017. That's what we wanted. seems to be rounding them. Oh, silly me, it's doing sum, F62 again. So let's change that to discrete. Now we're getting good readings. We do unfortunately still have this, these null values. These null values are unique. They are not connected to a country. This is just where they're setting country. They're categorizing here. North America, not classified. Oh, and this actually doesn't even make sense because this has been reformatted into alphabetical order here. So there's not even a section of the North American countries in this. It's a little mistaken. I'll switch it to an attribute, or I guess we do a dimension. Dimension's going to flatten it, so I'll switch back to attribute, make sure we don't lose anything there. No, it looks like we lost it for good, so I'm going to undo a couple of times. There we go. So again, this is the type of stuff you'll have to wrestle with to kind of get your data to do what you want. Let's see. I'm still unable to create a map. So I'm going to go on data source and click this down arrow and go to geographic role. We see down here. And this is a country/region. So when I click that, you'll notice that this show me option for a map shows up. And if we click it, now we're getting what we want. So that was a bit of a wrestling match. And if you hover over, you should see the fertility rates for these countries. And you'll see like Cayman Islands was one that was blank. Or we're at a null set and it just doesn't have any data. You'll see that the still says F62 on the hover. We'd have to change that column name if we wanted to do something else with it. Okay, so that was pretty messy data. One more example of messy data. And this will be the end for this video. I'm going to choose one more text file. Let's go back to our COVID. Well, so first of all, let's just do what we were doing earlier. I'm going to grab 319 and hit open. So this is organized better. We got country region. That's helpful. Confirm deaths. And we got latitude, longitude. So I believe, what we want to do here, if we got a new sheet, is do country region, for instance, get our map. And we could do number of confirmed cases here. I'll drag that to size. I'm going to say it's in sum right now. Let me change it to discrete. Ooh, that got worse. And it's an attribute, I think we could argue. So I'm going to blow out the size a little bit. Yeehaw. And then go to color and bring this down a little bit. So it's pretty straightforward to take like a timestamp here and show a moment in time on a map. If we wanted to show multiple moments on a map, really the only way that I can think of doing that, showing values over time, variables over time, is with an animation. That's a little bit beyond our expertise level, certainly on our third day of Tableau. So what can we do with this? Well, I mean, we could do multiple timestamps, but some of you may have noticed that there's what's it called? Time series data. So hey, we could do something with that. We could at least make like a bar chart, right? Well, let me just show you what happens if we try to do something with that. Just to be clear, it is doable, but what I'm pointing at is our data gets messy here. Okay, so COVID-19, I'm going to go into the time series and I'll do confirmed. Okay, so we got country region again. That's really nice and friendly and useful. And then you can see our time series and watch as all the numbers go up. Okay, so if I go to sheet 7 here, and I'll take country region, we can drag that guy over. We'll get our map. We can hover over and it'll tell us the names of the countries. So what about our time series here? Well, I could take, one of these and drag it over to say size or something like that, and it'll change, right? So that kind of works. But if I wanted to compare that to, let's see, that was 3, 9, 20. Oh, it's doing sum. So So discrete attribute. There we go. Uh-oh. We're getting an asterisk here. Let me see if it's more friendly as a dimension. Yeah, there we go. It's a dimension. So he's got to be comfortable playing around with it. Let's see the 3920 0. That seems wrong. Well, we'd have to look at the data, I guess. Anyway, so let's say we want to compare that to like 2.9 or something like that. Well, I'm having trouble finding 2.9, and the reason is you see how these dates are not formatted properly. They should have this should be not a 2.120, but an 020120, so everything has the same number of digits. That would make it so that this shows up in numeric order correctly. But here's 2.9. So what can I do with this? I mean, if I drag it up, how am I going to show this separate from the one I'm already showing? Could drag it into like color or something like that. I mean, that's just not really going to work, right? Well, let's see. It goes from 0 to 7161. That's kind of cool. Here you go for 2.9 to 3.9. So it's showing up in the details just fine. My color idea didn't really work. So let me undo what I did, because this looks a little better. And I'm going to take 2.920 and drag it into detail. Do we have 1.920 or am I going back too far? Looks like the earliest we have is 1.2220. I'm going to drag that into detail as well. So what we should be able to do is hover around like a place like China, and it will show these 3 separate values. Here, let me hover again. And if we wanted to adjust the order, I would think we could bring country up or down. And let me try that again. Oh, that did not affect it, it appears. Let me see if I drag that to the bottom. 3.9. Let's see, that's 1. Oops, let me undo that. This is still set the sum also. So discrete and dimension. There we go, finally. Well, first of all, sorry if I lost anybody. It did get a little boring and lengthy. But the reason for that is because I'm trying to create, let's see, maps from 4 or 5 different data sources. And really, I'm trying to illustrate the different issues y'all are going to run into when you're trying to make these maps. I solved all these problems just by playing around in Tableau. I found one helpful bit of advice would be if you're working on a map and you're not making progress on it and you're going to try something new, create a new sheet. Don't work from the same sheet. I have tripped myself up more than once doing that. So what I would encourage everyone to do is find your own data that you can map. Again, here's all the data that we used today or in this video. If you go to an open data source, take a look at anything you can find that's map based. And again, we can work with a lot of different stuff, but GeoJSON, that's great. Latitude and longitude is great. And then anything that just defines county, city, country, all that stuff will be it'll be in there. We'll be able to map it. Let's see. Maybe I didn't pick the best. Well, this is what I wanted. And you'll eventually end up on a list like this. And here's maps. So that's one way. You can cut through the extra data sets and just get the stuff that you're going to be able probably to map, depending on, again, if it's like a block or a street address, it's going to be a little bit more difficult. Well, this is some pretty boring data, but I bet there's some interesting stuff in here. So I encourage you to practice that. If you run into problems, you can't get your map to show up the way you want, let me know and I'll try to help you out. Just tell me what your data source is and where you got it. Other than that, again, I want everybody to think about what you can do for the final project. I'm going to be posting links to example geospatial analyses. I've already started doing that on the blog. I'll try to populate Moodle with that as well, so it's a little more useful to us. All right, thanks a lot, y'all.